wings to fly won't take you to the stars. Use the metal for a boat and you won't sail too far. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out the secret pin code, pin code, pin code, pin code, pin code, pin code, pin, 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 pin. Science can be tricky, it can overheat your brain. Science can be hard to chew, each bite can be a pain. Stop sitting in the dark, stirring metal pots about. You will change your life forever when you figure out the secret pin code, pin code, pin code, pin code, pin code, pin code, pin, 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 pin. The secret pin code, pin code, pin code, pin code, pin code, pin code, pin, 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 pin.
Pedal, people. Keep it up. 1, 2. Put your beak into it, or your snout. Whatever's in the middle of your face.
Whoa, hey there, sweaty sports people. Anybody seen my honey? Oh, there you are.
Hey, Sky Bear. Why do you always miss our daily exercise sessions?
Is that a joke? There's no gravity here in space. All that exercise for what? There's no need to walk up here.
But you won't be up here forever. You are planning on going back to Earth someday, right?
Well, of course I'll go back sometime. Though if I'm being truthful, I'd live like this forever.
My friend, you must see the importance of staying in shape, especially when you're in null-gravity environments. Your body needs it.
But just floating is awesome.
You should never take your health for granted, you know. If you don't look after yourself, someday you'll be sorry.
My health is fine, thanks. I'm strong as a bear.
Maybe for now, but when you're back in gravity again, your bones and muscles are not going to be nearly as strong as they once were.
That might be true for all you guys, but we bears have muscles like steel, and our bones are like granite.
Well, you're sort of right, but I still don't think you're getting it.
Incredibly, our bones are about 4 times stronger than steel. The secret to our bones' amazing strength lies in what bones are made of and how they're put together. The outer layer of our bones is a hard, compact mineral composite, but the inside is a collagen-based honeycomb matrix. That makes the bones somewhat flexible, and that flexibility protects us from breaks and helps make our bones able to withstand enormous pressure. If the entire bone were just the hard substance, it would be more vulnerable to breakage. Glass is a good example. If you smash glass with a brick, don't do that. It falls to pieces. But notice that when glass is broken with a gunshot, if the cracks don't spread, the glass will stay intact. The cracks are what bring about further breakage. So, the flexible collagen within our bones prevents cracks and also prevents cracks from spreading, making our bones not just stronger, but less breakable.
Told you they're strong. Well, didn't mean to interrupt your sweat festival. Have fun riding bikes that don't go anywhere. Toodles!
Just forget what the bear said. Just 5 more minutes of pedaling, then you can go fly all you want.
Just beautiful. What?
Is everybody all right?
Yeah, fine, great. Holy carrots! We're upside down, right? If I had to guess, something shorted the controls out, and this moon's gravity pulled us down.
Can't say the view does very much for me. Don't see any hotels.
I don't know about you, but my seatbelt seems to be really stuck. I can't get out of this thing at all.
Don't bother to try. The short will have affected every electronic system on the ship. We need to turn on the emergency generator. Then all the systems will reboot.
But who's going to turn it on if we're all hanging here upside down?
Well, there's Barry.
Well, we're gonna be here for a while.
What just happened? Please? What? Well, whatever it was is a humdinger of a snafu. Oh! What's going on with me? Something's really wrong. Oh, gee. Golly, I can hardly move. I'm a bear. A great, big, strong bear. Somebody help me.
Hey, that's Barry!
Barry, help me!
Oh, boy. Are you there? I can't see you.
Yoo-hoo! Just look up.
What are you doing up there?
Waiting to be rescued by a bear.
All right, here I come. Turnips. What is happening to me? I can hardly move. Must have broken something in the crash.
It's what we warned you about, Mr. Steel and Granite. Your body got used to no gravity. You haven't used your muscles in a long time, and they've gotten weak.
Modern humans appeared somewhere between 100,000 and 200,000 years ago. And now humans have become the most powerful creatures on Earth. Our bones are stronger than steel, and our muscles can be strong and resistant. Of course, this wouldn't be the case without the effort of regular exercise.
What now? Bears are just born strong.
Well, it's true that with all our convenient inventions, physical labor is not as necessary to ensure survival as it once was. You can order pizza for dinner by moving a couple of fingers. And going to work just means getting into the car, pressing the pedals, and turning the steering wheel.
I'm working up quite an appetite. Turning this wheel, hitting buttons on a keyboard. Oh!
While our lifestyles may have changed, our inner construction is essentially the same as our ancient ancestors. All of our modern conveniences have led to an increase in eating unhealthy food and a decrease in exercising. And as a result, many people are now overweight. In fact, almost 2 billion people worldwide suffer from the disease of obesity. Our bodies naturally conserve energy use and adjust to our intake and activity level. If we don't move enough, our metabolism slows, and we lose muscle strength and bone mass. That's why it's so important for astronauts to exercise.
I get it now. The exercise. I'll join in from now on, guys.
Congrats on the breakthrough and all, but could you maybe get us down from here first? We need to turn on the emergency generator, or else we'll be hanging here forever!
But you have to be careful! Your bones are fragile right now! And while the gravity here on the moon is lower than it is on Earth, one careless move could cause a serious injury, even to a big, strong bear. And if you get hurt, we're all in serious trouble! But, you know, no pressure!
Where's that generator? I hope it isn't far.
The generator turns on with a big red lever. It's near the control panel. You can't miss it.
Well, that couldn't be in a worse place. Careful. Careful. This is no big deal at all for a normal bear, and a really bad idea for the bear with glass bones. I am a big, brave bear.
But you have to be careful! One careless move could cause a serious injury, even to a big, strong bear.
Attention, the emergency generator has been activated.
While many people dream of simply taking a pill to control weight gain and prevent the loss of muscle mass, no such pill exists. And that's a good thing, because the best prevention and the best cure for obesity is eating good, healthy food and getting plenty of daily exercise. Then you'll be strong, healthy, and ready for anything.
Pedal, people! Keep it up! 1, 2! 1, 2! That's it!
Put my ears into it.
Hey there, sweaty sports people.
Don't forget the tail of the broken bear. Pedal, or this could happen to you.
Never! Faster! Faster!
Exercise, yeah. Take care of your muscles and bones, or you could end up exactly like me.
There we go. It's nice spending time on something sort of special that'll be a nice surprise for your friends.
What a massive asteroid! Yeah. And it's about to collide with a nearby planet. But don't worry. Fortunately, that planet is not Earth. Holy carrots! Oh, that's gonna be crazy great! We'll totally see it burning and exploding and stuff, right?
I imagine, yes. It will be an unforgettable event. But in advance of the collision, we are going to conduct a one-of-a-kind experiment. We aren't able to study this sort of phenomenon every day, right? We just need this great big asteroid's help.
But isn't that dangerous?
Not at all, my dear worrywart friend. There's still plenty of time.
Surprise! Heart pendants!
Heart? Gimme.
Excellent craftsmanship.
Fine. Now that we're so fashionable, let's thank our dear friend here for the lovely gifts and turn our attention back to the asteroid. But prior to undertaking our exciting experiment, I'd like to ask, how much do you know about electrical currents?
Electrical currents are a kind of energy that powers all of our stuff.
Light bulbs, mixers, toasters, microwaves, vacuums, fridges, computers, our own ship all work because of electricity. Electrons moving along conducting wires are what make an electrical current. If the electrons could move through empty space, we would have perpetual energy with no loss.
Hooray for endless power!
But no, electrons can't flow in a vacuum. But among metal atoms, it flows quite nicely. And when those electrons collide with the metal atoms, they end up giving those atoms part of the energy that they're carrying. Which means, unfortunately, the energy will run out over time. Isn't it considerate of the electrons to share like this? No!
What does the asteroid have to do with this?
Patience, my enthusiastic friend, patience. I want that to be a surprise. Pin, are we in position over the asteroid?
We're right where we should be.
Excellent! When we first came across this asteroid, I realized we could do something awesome. We could all have a unique, fascinating experience. But first, we need to put on our warmer spacesuits.
I do not do cold. Or surprises. Well, unless they come from Rosa.
Remember, do not take off your spacesuit. There's no air, and you'll freeze solid in about 12 seconds.
And also, my excitable friends, the asteroid's gravity is quite low. One careless jump and you'll fly off into space like a wee furry rocket.
Hey, this is really fun. This is the big surprise, right?
Actually, it's not. I'm not exactly sure what's going on here.
What the slop are you guys doing up there? And how come I'm the only one not floating, huh? Is this asteroid saying that I'm fat?
Maybe because you're the only one not wearing one of the pendants you gave us. What did you make these things out of, Rosa?
They're just paper. Oh, and I also glued little magnets to the back so you could hang them on the fridge. Oh, and also a half tablespoon of love.
Now I understand. The pendants did this.
Because of the love?
Because of the magnets, of course.
Hang on. If you wear a magnet, you can fly?
Not really. This is just because magnets aren't compatible with superconductors.
I don't understand that at all. Could you explain it one more time in bird brain terms?
Of course. Please try to keep up. The atoms in conductors are constantly vibrating, and the electrons are colliding with them and giving away energy. Because of this, the electrical current decreases. And the higher the temperature, the stronger the vibration and resistance for the electrons and their energy.
So, if the temperature decreases, the resistant force will decrease too?
Yes, that's right. Exactly. Moreover, though, in 1911, a Dutch physicist, Heike Kamerlingh-Onnes, discovered that if the temperature of the conductor is lowered to minus 270 degrees, the resistance force disappears completely. And this phenomenon is now called superconductivity. And the conductors that can be cooled to do this are called superconductors.
You move faster with nothing in your way? That's not exactly an earth-shattering revelation. What does all this got to do with Rosa's magnets?
Quite a lot. All superconductors have a unique property in common. Superconductors and magnetic fields repel each other. That means that anything magnetized would float over a superconductor. The asteroid we landed on is a conductor with a unique composition. But because of space's ultra-low temperatures, they're very close to absolute zero, then the asteroid becomes a superconductor, and the superconductor asteroid pushes out against the magnetic field of the magnets on the back of our pendants.
Sorry about that. My feelings won't be too hurt if you throw them away. That's not true. They'll be crazy hurt.
So if we take these hard things off, then we'll float back down, right?
Don't do that. Stop. There's no air, remember? And it's cold, too.
So we just float here forever?
I'll pull you back inside the ship. No worries.
Be careful, my friend. If you jump too high, you could end up floating forever through the vacuum of space.
For the record, I didn't want to come out here in the first place.
Is it me, or is it getting colder out here, guys?
Yeah, that's the lack of energy. We're all going to get very cold. But don't worry, we'll run out of air long before we freeze.
Gee, thanks, Pin. We all feel much better now.
Look at that.
Well, looks like we don't need to worry about running out of air after all. The asteroid is going to collide with the planet before we run out of air. Surprise.
Did I mention I don't like surprises? But I hate this one more than all the others put together.
Rosa, go and fire the ship's engines up. We can use it to change the asteroid's course, and then it will not collide with the planet.
But I don't know how to pilot the ship.
You'll have to learn as you're doing it. That's how all the best pilots are trained. That's a lie, but you got this. You're looking for a big switch that says on. Or no, if you're looking at it from the wrong side. Nine! That's the Boogie Wonderland switch! Keep looking! Nine! Headlight! Okay, at this point you've literally hit all of the wrong buttons. Nine! Laser cannon! Laser cannon! Laser cannon!
Try not to laugh so hard, my friends. We still have a limited air supply.
I think I figured out how to turn on the heater. Should I use it to warm you up a little? If you stay out here much longer, you'll turn into a bunch of Riki-sicles.
Of course! You're a genius, Rosa! We should warm the asteroid with a heater. It'll stop superconducting if we're successful at warming up its temperature. Theoretically, the superconductivity of the asteroid will now decrease, and we will return to the ground.
Crash?
It's kind of a bummer superconductors only work when it's super cold. I wish they worked all the time. Put a magnet in my pocket, then whammo, I could fly.
That would be awesome, my always dreaming friend, wouldn't it? Hopefully that day will come. Someone will come up with a superconductor that works at normal temperatures. Whoever does will be a shoo-in for the Nobel Prize, and they'll get their own reality show.
When that day comes, the world at last will see the noble penguin fly.
The father of superconductivity is the Dutch physicist Heike Kamerlingh Onnes. In 1913, he was awarded the Nobel Prize for his discovery of this phenomenon. His motto was, "By measurement to knowledge." In 1962, Soviet physicist Lev Landau received the Nobel Prize for the mathematical theory of superfluidity. He also happened to have a theory for life, which was that everyone deserves to be happy. In 1972, 3 American physicists, John Bardeen, Leon Cooper, and Robert Schrieffer, received the Nobel Prize for further developing the theory of superconductivity. And in 2003, 3 more scientists received the Nobel Prize for significant contributions to the theory of superconductivity: Alexei Abrikosov, Vitaly Ginzburg, and Anthony Leggett. Ginzburg, whose youth was during the Second World War, joked that his love for lower temperatures springs from an especially cold winter in 1942. Recently, new superconductors have been discovered that work at the temperature of just -170 degrees Celsius. Perhaps someday we'll find substances with zero resistance at room temperature.
I feel bad. I feel like I don't have any talents. I'm just so uninspired.
We fly here, we fly there, and no matter where we go, same old stars.
Oh.
Day, night, day, night, day, boring and dull.
In general, my life is fine. My experiments are going well. fascinating results and all, but nevertheless, something's off. I kind of feel like all the walls are pressing in on me.
Stars all around us, but I long for a mud pit to wallow in. Nice and runny. I'd love it.
Well, it's pretty clear what's going on here. Everyone seems to be showing symptoms of common space depression.
Depression? How depressing!
It's not fatal. You'll be fine. There are a number of cures. First, you should take a nice warm bath. Then take some time off.
Time off?
Yeah, a break.
I'm the party penguin! Cannonball!
What's going on?
What's it look like? A warm bath, party, a little time off, like you said.
Well, that certainly is a giant bath. Hang on, what's this? Tell me you didn't use our entire soap supply for this.
Yeah, shampoo too. Best bubbles ever.
You said a nice warm bath and time off would help us with our depression. Wonderful therapy, by the way. I already feel 100 times better.
Your treatment really hit the spot.
Thrilled to hear that. But our well-being would be even more endangered if for some reason we lost our soap supply.
Cleanliness isn't nearly as important as feeling positive and happy again. My dear obsessively clean friend.
Not nearly as important? All our species would have died out if it weren't for a little thing called soap.
Died of depression?
Yeah, that too. The origins of washing with a substance come from prehistoric times. The first substance used wasn't actually soap, but clay.
But isn't he dirtier now than when he started?
Not at all. The clay was actually as good as modern soap for cleaning. But even with the invention of soap, our ancient ancestors were not aware of the value of keeping themselves clean. And in the big cities of the Middle Ages, people's life expectancy was often shortened by disease. You see, infections spread quickly in densely populated areas, like cities. And it wasn't until the late 18th and early 19th centuries that there was a revolution in our understanding of the importance of keeping clean. And due to that change in behavior throughout society, life expectancy grew 30 years over time.
All right, I've got it now. To stay healthy is to stay clean. But up here in outer space, there aren't microbes or bacteria. Soap doesn't matter here.
Up here we can wash up with only water, right? But it did wash away our depression. So Dankeschön, beautiful bath bubbles.
I just feel so uncomfortable. In my own skin, it itches bad.
Don't turn the light on, 9. I'm under the weather. I can barely get around. My feet keep sticking to the floor.
Everything's all right in general. My experiments are fine. Interesting results and all. But I feel like something is creeping up on me.
Oh!
Dirty and clean. Dirty and clean.
Mud bath. Mud bath. My kingdom for a mud bath.
Pellets. Now do you understand how important soap is to our state of well-being?
I still don't understand what the big deal is about soap. Why can't we get clean by using just water?
interesting question. Have you ever noticed that hands really are harder to wash without soap?
How come?
Because grease cannot be dissolved by water alone. The reason for this is that water molecules have an electrostatic charge and oil molecules do not. Water molecules are shaped in a way that makes them hook tightly together, creating surface tension. And without something extra to hook the water molecules to the grease escapes the water every time. Soap molecules are the bridge between water and grease. One end of a soap molecule has a negative charge and can interact with water molecules. The other end is nonpolar. That means it has no charge at all, and that the end can attach to grease molecules. In addition, the nonpolar ends of soap molecules attach themselves to the nonpolar grease molecules, and the soap molecules end up gathering into a sphere around the grease molecules. Those spheres are called micelles. Whenever we wash anything in soap and water, millions of micelles appear. And by agitation, the micelles tear the dirt and grease away from whatever is being washed. And in the process, micelles remove dangerous germs. Clear water then rinses away the dirt containing micelles, and we are clean again.
So we'll just stay dirty until we find some soap molecules?
There must be an alternative to soap. We don't need an alternative. It has to be possible to locate some soap molecules in another place.
Yes, dear friend, that's right. Good thinking there. In fact, those molecules could be found anywhere. You know what? They could be found in us.
What? Really?
For instance, similar molecules help us breathe. Amazingly, there are cells in our lungs that function like soap molecules. When we inhale, the air flows down the trachea through numerous small tubes called bronchi and finally fills hundreds of little sacs called alveoli. From the alveoli, oxygen gets into our blood vessels and is carried throughout the body. Now, on the inner side of the alveolus, there is a thin film of liquid, and when we breathe, this liquid has to expand and contract easily. If this film consisted of just water molecules, it would be very difficult to stretch, because every water molecule is positive on one side and negative on the other. They are firmly attached to each other. Fortunately, there are special molecules in our lungs that interact with the water molecules like soap does. Those molecules get between the water molecule and reduce their mutual attraction, and that makes it possible for us to breathe easily.
All right, then. There are some soap molecules inside us. Who are we going to get? Our soap from? Eeny, meeny, miny, sheep.
No. We won't be cutting anyone up and harvesting soap from them. I just remembered a secret recipe I learned from my grandmother. My lousy memory. Can't believe I just thought of it now. Now, this will help us get nice and clean.
Hold up. Come on. That'll make us more disgusting than we already are.
My great-grandmother was never wrong about anything. An egg yolk, Granny would say, works when you don't have soap.
Great Granny's right. Yes, I should have thought of this earlier. Egg yolks contain a substance called lecithin. Here's another use for eggs. The lecithin molecule in egg yolks has a charge on one side and is nonpolar, has no charge on the other. This allows a lecithin molecule to attach itself to a water molecule with a charged side and a grease molecule with the nonpolar side. Sound familiar? That's right. Lecithin molecules are similar to soap molecules, and that means you can wash your hair with a fresh egg yolk.
fine.
It is so good to be
forever.
You smell no better now.
Oh, yes, what they say is true. There's nothing like being clean in the morning and at night and in the afternoon.
Your attention, please. I would like to share my new poem. It's pretty short, but it's good. To be clean is to be not foul. It is more important than you think. And thanks to one special owl, all of us no longer stink. Good, right?
It'd be better if I was in it.
Bravo, bravo! So very talented, don't you agree?
I've heard moderately
Wunderbar.
worse.
Quite
Not half
moving,
bad,
right?
right?
Let's all do a toast in honor of our precious savior. Yay for Olga! Where is our guest of honor?
Oh, Siggy, I am depressed. Everyone else is happy because I helped them fix their problems. But what about my problems? Maybe I should try knitting. Sigmund, are you even listening to me?
Happy birthday to you. Happy birthday to you. Happy birthday, dear Rosa. Happy birthday to you.
Now it's time to, set off the fireworks, right?
Fireworks, fireworks, fireworks.
The natives are getting restless. Hurry up there, Daco.
Cool your horns, my impatient friend. Accuracy is most crucial in this process, as is being cautious.
Ah.
Whew. Be careful with these things, Wally, please. They can very easily go off by themselves.
What have we done? Please say you can invent more fireworks.
Well, first, this was not remotely my fault. And then second, where can I find more firework ingredients? We're flying through space!
This is bad.
Although... Hey, yeah!
What's happening? It's fireworks time, isn't it?
Just give me a few moments here, my lovely birthday girl. There's a little question I'd like to ask everybody first. Here it comes. What do you know about the life cycle of a star?
What do you mean, a star's life cycle? Stars just shine forever, right?
No, siree. Just like everything else, stars come into the universe, they live, and they die. The process just takes much longer with stars. Very much longer, in fact. It takes billions of years.
A new star is created in a cloud of dust and gas called a nebula and consists mostly of hydrogen and helium atoms. When the dust and gas become heated through compression, if the mass of the cloud is dense enough, the temperature during the compression as well as pressure becomes so high that the atomic nuclei start joining and thermonuclear reactions take place. An enormous amount of energy is generated and the compressed gas cloud starts shining, turning into a star.
Are you saying there was a time our sun was a cloud like that?
Like every star was, yes. But then, with time, it transformed quite a lot, growing into the sun, with which we're familiar. Thousands of years later, planets gradually formed around the sun. And one of these orbs eventually developed life. We're that life.
While I love party-killing science lectures as much as the next girl, I was promised fireworks.
Yeah, Rosa. But still, gee, this is interesting And can you tell us the age of our sun?
We can roughly estimate that it's in the vicinity of 4.5 billion years old. It's been around a while. Certainly it's mature, not a little baby anymore.
Once a star has been formed, nuclear fusion occurs constantly in its core, using up hydrogen and releasing immense energy, enough to push against the force of gravity and keep the star in balance for billions of years. But this process is not infinite. Eventually, the hydrogen will be depleted and the star will either collapse or explode.
Goodness, are you trying to tell us that our very own sun is going to, come to an end?
What? Our sun will die? No more parties or fireworks? Hold me! Save the planet! Save the whales! Hey! It's a madhouse! A madhouse!
There is no need for any of us to panic. The life cycle of our beloved sun will not end soon at all. I'd say we have about 5 billion years before that.
I'm beginning to think nothing's going to blow up here. Are you telling me my birthday isn't worth fire in the sky?
Have patience, our dear porcine guest of honor. Something far better than fireworks is on the way.
Yeah, lots better, yeah. It is, right?
Precious friends, we have quite an enchanting opportunity to witness the end of the life cycle of one of the largest stars in our galaxy. May I present Betelgeuse?
Betelgeuse is one of the largest known stars and is one of the brightest stars in the constellation of Orion. Betelgeuse is 700 times bigger than our sun and approximately 100,000 times brighter. As is the case with all giant stars, Betelgeuse burns its hydrogen faster than smaller stars. It is believed to be in a late stage of stellar evolution and is expected to explode as a supernova within the next million years.
And what happens to stars when they get to the end of their cycle?
Hey, I know! They fall right out of the sky! If you see one falling, you can wish on it and stuff. But they're not as pretty as fireworks are!
You're wrong there. The final act in the life of a star is an awesome spectacle, better than the best fireworks display ever! We've come to the stellar neighborhood of Betelgeuse to view this breathtaking cosmic wonder!
Should we get closer? I can't see it! Just a bunch of regular old stars. So what? If we move closer to the star, is the ship going to melt or something?
I'm melting. This vessel is capable of withstanding ridiculously high temperatures.
There is no need to move closer, trust me. From this position, everyone will see everything clearly.
You can start the show now! Preferably while it's still my birthday.
Frankly speaking, it should have already started, according to all my calculations. I don't understand it. Sorry, let me just calculate all of it again.
Stop, sheep. You know how to drive the silly spaceboat, right? Let's fly a little closer to this star action.
But didn't Daco say we could see it all from right here?
Well, Daco said a lot of stuff. He told us this thing was supposed to start hours ago. What if the show has started, but we're just too far away to see it? Sweet Wally, you're always so kind to me. Won't you give me this? For my birthday? Closer! Come on, fly closer! Oh, this is awesome! It's for me! Yeah! It is better than fireworks! Well, it is crazy warm, all right. But from here we will totally see everything!
Turns out I just forgot to carry the wand, silly me! And now I can say with absolute confidence, the spectacle will indeed be starting quite soon! Why are we right next to the star?
Much nicer view, right? I just thought we'd be able to see everything so much better from here.
You just don't understand a star's life! At the end of the life of a star, the close of its life cycle is an intense explosion! 10 seconds from now, Betelgeuse will increase its volume 1,000 times.
When there is no hydrogen left in the center of the star, fusion stops, and the star begins its collapse. This leads to intense pressure and heat, which in turn will lead to an explosion. Exploding stars become much bigger and brighter for a time. Sometimes the explosion of a star is the only time it is visible to us here on Earth. Exploding stars are called supernova. Betelgeuse may become a supernova sometime soon, although nobody can say exactly when it will happen. It's more likely that the flash of that supernova will be seen by a future generation. Perhaps they will see a second sun in the sky.
Yikes! Sweet sauerkraut!
My birthday!
That was not fun. I'm getting way too old for this stuff. Dumb star.
That's just great. I was way too scared to even look at the explosion. All I wanted were some dumb fireworks for my birthday!
Look at that.
Of course! So, Betelgeuse has grown so much it's nearer the Earth. In fact, it seems it's shining bright enough now it's able to give our sun a little friendly competition.
Isn't it just beautiful? It's the best birthday in the history of forever. Forget silly old fireworks. I got a whole new star!
Stupid cliff! Why can't rocks be soft?
Can I help you? Guess not.
Come on. No! The only cute thing on this whole planet!
You see what we've stumbled upon? This new planet is amazing! We were even lucky enough to find water! Just think of all the amazing things we can find! Maybe even life!
Can we call this planet Crashville?
Let's get some other suggestions first. Whoa!
I'll be. This place can get all the way down to 100 below.
Whoa! 100 below what? Whatever it is, I'm freezing my tail off.
Come check this out. Something's down here.
It seems you're right. Whatever's inside certainly appears to be living. Phenomenal!
It's like a present! Let's open it up and see what's inside!
Wait! We must be careful. We can't hurt whatever's inside.
I've seen this movie before, and what happens next is never good. This is a bad idea, I tell you. Explorers bring back something cool from space. They take it all the way to their spaceship, they let their guard down, and disaster strikes.
Hang on. What disaster?
Bad disaster. Let's say the kind involving monsters. Imagine you wake up and decide to check out our mysterious life form. But when you get in there, seems the ice has melted already. You consider waking someone else up, but surely everything is fine. But wait, what's that noise?
Hang on, guys. Maybe we should wait and see what's inside first, before it's free.
Yeah, and this is how we find out!
Stop! There is a way to see inside without breaking it out.
Wait, is this like a magic trick?
Science is better than magic. Ladies and gentle creatures, please give a hand to our assistant in 3, 2, 1. Can anyone see what is inside this rabbit?
No, we can't. He's solid.
That's correct. There's no way we can see what's inside him because he isn't transparent.
I believe it's due to the power of light photons. Visible light is pretty weak. Photons simply don't have the power to pass through solid objects. When it encounters something solid, like crash, they just get reflected or absorbed.
That's right. Your average photon is just too weak. However, we need to use something a bit more powerful. Let's look at a little bit of radiation.
Oh, of course. X-rays have higher energy and can pass right through our soft tissue.
But if X-rays go straight through our whole bodies, we still won't be able to see a thing.
No, there are some things even these X-rays aren't able to pass through. Harder objects like bone just end up reflecting the rays. Let me show you. Here's how it works. Our bones are dense, but our other parts like skin, fur, and muscles are soft. So the X-rays pass through the soft stuff and stop at the bone. So, whenever we look at an X-ray, what we see are the parts that reflect radioactive photons. So we can see Crash's unique diet. Anyway, are we clear now?
I'm not clear. If we were, we wouldn't need X-rays.
That makes so much sense. We should X-ray our findings before breaking it out.
How about we leave it on the planet? Just skip the X-ray entirely. No one asked me.
I second that.
One moment.
Well, what did you see?
Wait, it's not that simple. We have to process it. Once the image is processed, then we can analyze our data. So thrilling!
Well, we are doomed.
No, don't say that.
By the time those images get processed, we'll all be eaten.
Oh, it's not true. Oh, help! We're all going to be eaten by a space cliché. Save me! Oh.
It's amazing! We discovered new life! I knew there was something incredible inside! Phenomenal!
Neato! This thing's finally almost melted.
What is that?
Hmm?
My beakers! Stop that!
Stop! Save yourselves! I'll destroy this thing.
Now, what gives? Well, thank goodness. I was freezing in there. Being stuck in someplace cold is basically the opposite of what bears are supposed to do.
But Barry, how did you get stuck in there?
I fell. Was not too bright. I thought it was mud, but no. I froze instantly. Guess the sun went down. Lucky it found me. It wasn't fun.
That's good. And I've seen this movie before, too. Too good. A lonely astronaut left behind on a planet.
No, this outdoes the movie. Barry, we're all just tickled pink that you're back, aren't we? Tickled pink? Guys, anyone seen Rosa?
When I get back, all of you are gonna pay. Oh, stupid planet.
X-rays are credited to a German scientist named Wilhelm Röntgen. After he discovered the X-ray, other scientists wanted to call it the Röntgen ray. However, he instead just wanted to name his discovery X-rays. Röntgen had stumbled upon a new type of physics that no one else really understood, but he knew that what he had found could be useful. Seeing people's bones could help medical science immensely. His discovery was so impressive, he won the very first Nobel Prize in physics ever in 1901. The medical community could now flourish with X-rays, and this paved the way for other scientists to now get physics Nobel Prizes too, like Max von Laue, who discovered more about X-rays, or William Henry Bragg and Lawrence Bragg, or Charles Barkla. They all continued to study X-rays and change what we know.